So in last class, what we have done, we have learned little bit of the different type of coordinates. Mainly three type of coordinate we have discussed. That is Cartesian coordinate and cylindrical coordinate and a spherical polar coordinate. These three coordinates are very important, and we have also seen that how we can write the expression of kinetic energy in the three different coordinate system. And today we are going to discuss a very important topic for the Lagrangian formulation, that is mainly the equation of constraint. And obviously we have to go for then degree of freedom. So we will discuss these two things in today's class. And tomorrow we will just go for a Lagrangian formulation with the help of generalized coordinate. Okay. So what is equation of constraint? The literal meaning of constraint is restriction. So when we are talking about restriction to motion, So when we are talking about restriction to motion, that is mainly identified as what? A constraint motion. So restriction of motion is actually identified as constraint motion. Restricted motion. Okay. So mainly there are two type of constraint. If we are talking about the configuration of a system, if I am talking about configuration, I am just talking about the geometric configuration. I will discuss it in a different way. But before that, let's go for what is the basic definition of two type of constraint, which is useful to understand the dynamics of a system. So first constraint is all about holonomic constraint. First thing is all about holonomic constraint, and second thing is all about non-holonomic constraint. So first we will go for holonomic constraint. Suppose I have Q1, Q2, Q3 up to n number of dynamical variable. So these are dynamical variable, and if the relationship between dynamical variable, these relationship is all about, let's say you can write some relationship, something like Q1, Q2, Q3, and let's say that can be written as Q1 is equal to 0. So this is nothing in form of equation. So if you have a relationship between dynamical variable can be represented in form of equation, or restriction to the motion can be represented as a form of equation, then this type of constraint are known as holonomic constraint. For example, I can just talk about simple pendulum. So if I am talking about simple pendulum, this is my simple pendulum, and this simple pendulum is constrained to move in vertical XY plane. So the story is very interesting. This is along x-axis, this is along y-axis, and this is the length. And for the simple pendulum, we all know that length of a pendulum is fixed. So obviously, if I want to represent the whole thing in Cartesian coordinate, so let's try to go for in a Cartesian coordinate. It is different issue that which coordinate system is more suitable, but today we are just going to understand mathematically what is going to happen. So obviously, if this particle will free, there is not any constraint, there is not any restriction, then obviously I can use the dynamical variable x, y, z. But the story is not so simple. The story is little bit constraint. There is not free particle. This is constraint. So first constraint is that the particle is moving in xy plane. So what is meaning of that? How I can represent it mathematically? I should write that z is equal to what? 0. If I am writing z is equal to 0, that means the motion is constrained to move in what? XY plane. But is that even if motion is restricted in XY plane, is that it is free? No, it is not free. Is that there is relationship between x and y? Yes, there is relationship between x and y. And what is that relationship? That relationship is that the distance, this distance is going to fix. So this can be written as x minus 0 whole square plus y minus 0 whole square is equal to L square. I am just using the distance formula and I am getting this relationship. So you can see, this will tell you a constraint. That means the particle is not moving along your z direction. There is not any movement into this particular direction. After then, there is another story, and that story is that the distance between the particle, so in the xy plane, the distance between particle and origin is going to be fixed. So x and y are not independent. They are basically dependent, and this is the relationship between the x and y. So here you have, this is your first holonomic constraint, and this is your second holonomic constraint. So from this type of thing, this is, we are just writing that the how we can write the holonomic constraint. Are people agreed with this? Yes? Okay.
Yes, sir.
Okay. So now similarly, I have two particle and both the particle is moving in xy plane such that distance between them is fixed. I can have this type of system also. So what is the story? Story is that there is two particle and this two particle is moving in xy plane. So if it is moving in xy plane, then what I can say? Obviously, if this particle will free, then there is x1, y1, z1. And yes, I am just taking this as origin. If this particle will free, that is x2, y2, z2. And now it is said that both particle is moving in xy plane. So how you can translate it in a mathematical form? The writing equation of constraint is nothing but the translation of your configuration in a mathematical term. Here we are just talking about configuration, how they are moving, what are the constraint, what is the restrictions. This thing we have to write in a mathematical form. And so we are using, so I can write easily z1 is equal to 0 because first particle is also moving in only xy plane. I can write z2 is equal to 0 because second particle is also moving in xy plane, but this is not enough. This is not enough. The story is something more. So this distance is always fixed. So whatever with the particle, wherever with the particle, this distance is absolutely fixed. So you can write x2 minus x1 whole square plus y2 minus y1 whole square is, let's say, some length square L square. So how many constraint equation you have written? You have written 3 holonomic constraint. This is nothing but the equation. This is nothing but the equation. This is nothing but the equation. And every equation is telling you some different story. Every equation is telling you some different story. You have to always keep in mind that all story of a configuration of your system must be written in form of mathematical equation. This is all about constraint equation. Are you people comfortable? So we will use it again and again and again. So we will take a lot of examples when we will go for the degree of freedom. But I think I should move towards non-holonomic constraint. By the way, right now, are you people comfortable? Okay. So let's go for a non-holonomic constraint. So this is a little bit more interesting. So when you have relationship between variables, and again, I am talking about the dynamical variable. So when you have relationship between dynamical variable, can be given as in form of inequalities, something like that. Suppose the relationship can be written in a form of inequality. Here, look at, here is not equality sign. This is in form of inequalities. So this type of constraint, there is restriction, but it will not tell you about the configuration of a system. The holonomic Constraint will always tell you about the configuration of a system, but non-holonomic constraint will not tell you about the configuration of a system. Look at what is tell. It will also tell you some story, but it is really different. Now look at, try to understand this thing. Suppose I have a box, and this is nothing but three-dimensional box, and you can just assume this is your three-dimensional box, and this is my origin. And inside this particular box there is a gaseous particle, and the length of box along x-axis is, let's say, Lx, along, or look, let's say this is your Lx, this will be Ly, and this will be Lz, and origin is at one of its corner. Then what you can say? You can say that x can be varied from 0 to Lx. Y can be varied from 0 to Ly, and Z can be varied from 0 to Lz. So this is your equation of non-holo, and this is nothing. This is not an equation. This is something like inequalities. You are just talking about the change in x. You are just talking about the change in y. You are just talking about the change in z. You are not talking about specifically what is the value of x. The x can be varied from 0 to Lx. X can be varied from 0 to Ly. X can be varied from 0 to Lz. So this is a very interesting thing, and you can represent this constraint in form of inequalities. In form of inequalities. So why this is identified as non-holonomic constraint. We can take another example. It's again a very fundamental example. Suppose I have a sphere, and the radius of this sphere is r, and this is in a vertical, and you obviously this is a sphere, then vertical thing will be always there. So you have a mass of m, and what you are going to do, you are just giving the little push. What will happen? If you are giving it little push, then it will just go and fall it something like this. So how you can represent it? Suppose this is my origin, and if I am talking about the position of the particle at some arbitrary time, then what you can write? You can write that x square plus y square plus z square, that's the distance of a particle from origin, must be always greater than equal to r. That means if your particle is just sliding over the sphere, this will be value of r, but obviously at some point of time, due to that particular gravity, it will just leave the surface, and that should be greater than r. And look at, this is not an equation. This is something like as a inequalities. So this is a very fundamental example of non-holonomic constraint. Are you people appreciating it?
Yes, sir.
Okay. So sometime non-holonomic constraint can be derived or can be written in form of velocity. What is meaning of that? Let me discuss this thing with the help of examples. So let us try to go for rolling without slipping. So what is meaning of rolling without slipping? Suppose there is some sphere or some disk or some cylinder. It is just executing a motion of rolling without slipping. What is meaning of that? Can anybody tell me? What is meaning of rolling without slipping? Suppose this is r.
V equals to r omega, sir.
V is equal to r omega. Very good. So what you will say? You will say velocity of center of mass is equal to, if it is moving in x direction, then velocity of center of mass is equal to omega into r. Omega is the angular velocity, and center of mass is moving with VCM. So look at, this is relationship between this linear velocity and this angular velocity. If this will going to execute it, if this condition is satisfied, then you can just tell about the condition of rolling without slipping. You can just tell about the rolling without slipping. Now, if you are doing all about the rolling without slipping, what is meaning of that? What is the basic mathematics behind that? From here we are getting this particular information. Now look at what is going to happen if the particle is moving some d theta angle, and this arc is nothing but what will be this arc? R into d theta. And if this arc is equal to, means R into d theta is exactly equal to the distance traveled by this particular sphere, and that is nothing but dx, then you are executing the condition of rolling without slipping. You can executing this condition. So what you are going to do? You are just going to write R d theta upon dt is equal to dx upon dt, and what you will get? You will get Vr into omega. D theta upon dt is nothing but omega, and dx upon dt is nothing but velocity of center of mass. So sometime you can have relationship between velocities, and this transform you as a change in d theta with change in x. Here I am not writing x is equal to r theta. It has not any significance. Here I am writing change in x is equal to change in is equal to r into change in theta. So whenever I am talking about change, I am just talking about the basically inequalities. I cannot say in form of equation. I cannot explain it in form of equation. So this is all about non-holonomic constraint. But for the examination point of view, or mainly for the formulation of Lagrangian, the holonomic constraints are more important and they are actually useful. So let's try to go for next condition, next definition, that is what? Degree of freedom. So let's try to go for degree of freedom. Okay. Let's try to go for DOF. Okay. First, I will give you some intuition and let's try to go for this particular intuition. What is this intuition? It's a very interesting. Suppose I have a 3 number x1, x2, x3. And there is not any relationship between x1, x2, x3. Then can we choose all these 3 independently? Yes, you can choose all these 3 independently. You can put x1 whatever number you want, you can put x2 whatever number you want, you can put x3 whatever number you want. You can put 1, -1, 10,000, isn't it? Okay. Now, if there is relationship between these variables, then you have, suppose this type of relationship is there, x1 plus x2 plus x3 is equal to 0. Then please tell me, how many variable you can choose independently? Are you able to choose all 3 variable independently? Are you able to choose all these 3 variable independently?
No, sir.
Never. How many variable you can choose independently? Any 2, any of 2. Okay. So if you have, so you can choose any of x1, any of 2 can be choose independently. Now suppose I have one more relationship, that is x2 is equal to x3. Then how many variable you can choose independently?
1.
1. So if I am talking about these two stories, if I am adding this story plus this story, then what is going to happen? Only one variable can be chosen independently. Only one variable can be chosen independently. Now, so you can see as restrictions, as the story of restrictions are going to increase, as the number of a story for the restriction are going to increase, our choice of independence is going to decrease. And this all choice of independency is actually associated with what? Degree of freedom. So let's try to understand what is your degree of freedom. So suppose I have n number of variable or n number of particle in a three-dimensional space, and that is all about configuration space. Suppose this is my origin. Suppose I have n number of variables. So suppose I have n number of variable, then what will happen? This is my first variable. This is, sorry, n number of particle. So this is my first particle. This is my second particle. This is my third particle. This is my fourth particle. And similarly, I have n number of particles. If all the particles are free, then how many variables you can choose into three-dimensional configuration space? Obviously, for the first particle, I can choose x1, y1, z1, 3. For the second particle, I can choose x2, y2, z2. For the third particle, I can choose x3, y3, z3. So similarly, for the n number of particle, how many independent variable you are going to choose? 3 into n. So degree of freedom. If your particle is free and there is n number of particle, then you can choose 3n number of independent variables. And each variable will tell you about the independent motion. So why we are just talking about for the dynamical system? Because they all are dynamical system. I am just using it as a dynamical system. That means I am talking about motion. And now if there are k number of constraint, what is meaning of k number of constraint? There are k number of different story which will tell about the restriction of a motion. Suppose there are k number of different story, not one number, two number, three number. How many number of different story? K number of different story, and all story will tell you something, a different story. For example, if I am talking about two particles moving in xy plane, means z1 is equal to 0 is an entirely different story than z2 is equal to 0. And x2 minus x1 whole square plus y2 minus y1 whole square is equal to L square is some another story. So if we have k number of story or k number of holonomic constraint, this is very interesting. K number of holonomic constraint. कितने number of holonomic constraint है? K number of holonomic constraint. Then degree of freedom is going to increase or decrease?
Decrease.
Decrease.
So it will decrease.
So that will be negative of k. So degree of freedom is defined for particles, for a n number of particles is 3n minus k. And it will tell you independent motion of a system. Degree of freedom will tell you independent motion of a system. That will tell you independent motion of a system. So whenever I will talk about the degree of freedom, I have to talk about the independent motion. Indirectly, mathematically, what you should tell, you should just tell all about the number of independent variable and each independent variable will associate it to a independent motion. Are you people happy?
Yes,
Yes,
sir.
sir.
So let's try to go for a sum problem based on degree of freedom and equation of constraint. So by the way, what is the most important thing to calculating degree of freedom? The counting number of particle is important, or is the writing the equation of constraint?
Sir, equation of constant.
Obviously. So first thing is that you have to learn how to write equation of constraint. So in a very crude way, what I can say that equation of constraint is just a translation. It's just a translation from English, Hindi, Bangla, Malayalam, Telugu to mathematics. Whatever be the configuration given in your system, and that all about the geometric configuration, you have to represent it in form of mathematical equation that is known as what? Equation of constraint. Are you getting my point? जो जो क्वेश्चन में लिखा हुआ है उसको आप मैथमेटिकली कैसे लेकर आ रहे हो? Mainly for the configuration that will tell you all about equation of constraint. So let's try to go for some basic problems. कुछ basic problem पर चले?
Sir,
Yes.
sir, in this formula of degree of freedom, this 3 is just an coefficient or some significance is there?
What? This
Sir,
3?
in this,
Because we
okay.
are talking about 3-dimensional space, na? Our configuration space is 3-dimensional space. Okay?
Okay.
So 3 into n minus k. For the first particle, how many? Suppose n is equal to 1. How many independent variable is there if it is free? 3 independent variable. x1, y1 and z1.
Z1.
Okay? And here 3n minus k. So if there is n number of particle and all are free, then what you will write? You will just write 3 into n. Yes?
Okay, so means this represent this dimension.
Obviously, but 2-dimensional is a constraint of 3-dimension, isn't it? So don't write this thing as 2n minus k for 2-dimensional. Okay,
Okay, sir.
just go for, because we are listen, your first rule is that you will keep your system free in a space. Are you getting my point?
Yes, sir.
And then you will find what are the possible degree of freedom for the free particle. Are you getting my point?
Yes, sir.
Suppose there is 2 particles are there, then what will be the possible degree of freedom if they are free?
So 3 into n only.
3 into, suppose there is 2 particle, I am talking about 2 pi, n is equal to 2. Then
Okay,
how many?
6, sir.
Then there is 6 degree of freedom. Okay.
Yes,
And
sir.
now you are adding all the constraint. Are you getting my point?
Okay.
And then you will just subtract it. So this is the best way to calculate the degree of freedom. Okay.
Yes, sir.
Okay. Chalo. So let's go for this problem. A particle is constrained to move in an inner surface of cone, with half angle alpha. Okay, as shown in figure. So you have to write, equation of constraint first in Cartesian coordinate system, second in cylindrical system, third in a spherical polar coordinate system. Okay, so let's try to go for this particular problem. इस problem को हम लोग कैसे करते हैं वो जरा देखने की कोशिश करते हैं. What is configuration? कुछ ऐसा ही है ना? Suppose I can assume this is my x, this is y, and this is my z axis. Half angle means this angle is alpha, and your particle is somewhere here. Okay. So what is value of n here? 1. N is equal to 1. And we have to write equation of constraint in a Cartesian coordinate. So first we have to write equation of constraint into Cartesian coordinate. So what is constraint here? So now it is given a particle is constrained to move in an inner surface of cone with half angle alpha. Can I say whatever is written into this particular English language, can I say that particle will always make angle alpha with the z-axis? Please respond.
Yes, sir.
Yes.
Yes, sir.
I can say that particle is always make angle alpha with the z-axis. This is the mathematical equation. This is the some translation of this particular configuration in a mathematical term. Now we have to write it. Now what is angle? Angle is nothing but the ratio between line. We have learned this thing from our class 7 or class 8, isn't it? If you want to represent the angle, you have to use cos, sine, tan. And what is this thing? This thing nothing but the ratio between two lines, ratio between distance, isn't it?
Yes, sir.
So here we are just trying to write the tan alpha. You can write cos alpha also. You can write sine alpha also. But I am just going to write tan alpha. So what is tan alpha? So obviously, first what we will do, we will just write this whole thing free. So if I will keep it free, then what will be my function? X, Y, Z in a Cartesian coordinate, isn't it? In a Cartesian coordinate, what are your dynamical variable?
X, Y, Z.
X, Y, Z. This is your dynamical variable. Now, so what is tan alpha? This distance by this distance, isn't it? This is your tan alpha. This distance by this distance. So obviously, what is this distance? This distance is always Z. So there is not any problem. This distance is Z. What is this distance? ये distance क्या है? Anyone? What is that particular distance? ये distance क्या है? बताइए.
Plus y square under the.
Very good. That thing is. यहां पर आप प्लीज ये मत सोचना कि ये y है. This is not y. This is something like this. This can be this distance. 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 So this is just a radius in xy plane at the z axis, at the z distance, isn't it? But I have to write each and everything into the Cartesian coordinate. So what will be my this distance? This distance should be measured as x square plus y square. So I have equation of constraint tan alpha is equal to x square plus y square by z.
Sir, can you explain once more sir, that distance?
What is this distance? This is radius. Are you getting my point?
Yes, sir.
Okay. So what will be radius? R x square plus y square. If something is moving in a circle of xy plane, isn't it?
Yes, sir.
So this is your R.
Okay.
Okay.
Okay, sir.
Okay.
Thank you, sir.
Okay. Now, if I am just trying to write it in a cylindrical coordinate system. What will be that? What is the dynamical variable into the cylindrical coordinate system?
R, theta, Z.
Very good. That is nothing but what? R, theta, and Z. So you have to use dynamical variable. That must be R, theta, and Z. Okay. And Z will be the exactly same Z whatever we are using into the Cartesian coordinate. है ना? So I
Yes,
think-
sir.
Yes, sir.
है ना? Are you getting this thing? दिखाई दे रहा है क्या? Okay. है ना? And what is R? What is R here? R is the same distance, isn't it? This is your R. R कहां से मेजर करते थे आप? You are. This is nothing but the जिस सर्कल में वो मूव कर रहा उसका रेडियस था, isn't it? In a cylindrical coordinate, remember?
Yes, sir.
So that is your R. R by Z. This is your cylindrical coordinate. Yes. And if you don't want, if you want, you can recheck with the coordinate transformation. For the cylindrical coordinate, you can write x is equal to r cos theta, y is equal to r sin theta. So now, what will be your x square plus y square? That is nothing but r. So your r upon z. Now, can you please tell me what will be equation of constraint in a spherical polar coordinate? I am just giving you 30 seconds. जरा बताओ क्या होगा? I am just giving you 30 seconds. Just please tell me what is your equation of constraint? So what will be your dynamical variable into the spherical polar coordinate?
R, theta, and phi.
Very good, very good. So that is r, theta, and phi. Okay. So what is theta here? What is definition of theta in a spherical polar coordinate?
Makes an angle with the Z axis.
Very good. That makes an angle with the z axis. So how many? What will be the angle from the z axis into this problem?
Alpha.
Alpha. So can I write theta is equal to alpha?
Yes, sir.
Yes. If you don't believe it, just put x is equal to r sin theta cos phi, y is equal to r sin theta sin phi. So what will be x square plus y square root under? बताइए. R sin theta, isn't it? You can take a square. R sin theta, you can take common. Cos square phi plus sin square phi is what? R sin theta. So you can write tan alpha is equal to this term is nothing but R sin theta. And what will be Z into the spherical polar coordinate? R cos theta.
R cos theta.
So that value is R cos theta. So R and R are cancelled. So what you have? You have tan alpha is equal to what? Tan theta? Isn't it? So that means theta is equal to what? Alpha. Yes? So you can represent your equation of constraint in any coordinate system. There is not any problem. But what is your degree of freedom? So degree of freedom is given by 3n minus k. What is value of n? Is 1. What is value of k?
1.
1. There is only one restriction is there.
Yes,
That
sir.
particle is always making angle theta, sorry, angle alpha with the z axis.
Yes, sir.
And this story you can write in a different language or different mathematical language. Here we are using the Cartesian coordinate system. Here we are explaining our configuration of a system in a cylindrical coordinate system. And here we are using the configuration of a system in a spherical polar coordinate system. So how many constraints are there? Only one constraint are there. So there will be 2 DOF. So you have 2 independent motion. You have 2 degree of freedom. How we can justify all this thing, we will discuss when we will go for Lagrangian and generalized coordinate. By the way, if I will ask you, in which coordinate system do you want to solve this problem? Mathematically, you can use anyone. But as a human being, we always want to be simplest calculation. Then which coordinate system you want to use? Obviously, we will go for a spherical coordinate system because it is written in a very simplistic form, isn't it? Here only one variable is used. For a cylindrical system, there is 2 variables are used to justify the configuration. But in a Cartesian coordinate system, we are using the 3 different variables to justify the configuration. So obviously, it is also my choice. I will also go for spherical polar coordinate is the best coordinate system. But yes, in the examination, they can ask you in any coordinate system. But obviously, they will never ask into the Cartesian coordinate system. Why they will not ask the Cartesian coordinate system? We will learn into next class. Okay?
Yes, sir.
Okay. So are you people happy with this discussion? So should I
Yes,
give you one homework?
Okay, sir.
Okay. So just post your homework. मैं इसे कल discuss भी करूँगा. So we will just go for one homework. आप लोग जरा इसे try करो करने का. Okay? Look at this is very interesting problem, and we will solve all this problem. Don't worry. So there is a hole on a table. Okay. So there is a mass M1. So this is a table. Mass M1 is constrained to move on the surface of table, and M2 is hanged vertically. M1 and M2 is attached to end of massless string. So first लिखो. Please mute कर लो अपने आप को, है ना? M1 and M2 attach to end of massless string. M1 और M2 किससे attached है? End of massless string. Where M1 is constrained string of length L कर दो, है ना? Of length L. Where M1 is constrained to move on surface of table. M1 कहाँ move कर रहा है? On surface of table. And M2 can only move in vertical Z direction. So find DOF. Okay, you have to find degree of freedom. So what do you have to write? First, you have to write the holonomic constraint, and then you have to go for finding the degree of freedom. I will appreciate if everyone will send the solution. And you can just write into the Cartesian coordinate system. Don't worry. Once you will know about Cartesian coordinate system, you can easily transform to any suitable coordinate system. Okay?
Sir, I have a doubt, sir.
Okay, sir.
Yes. What is your doubt?
We write degrees of freedom in spherical polar coordinate system is easy other than 2 systems. Why, sir?
Yes. Why? You will see when we will solve the problem. Okay?
Okay, sir.
Okay. And one of the reason is that for writing the equation of constraint, we are using only one variable into a spherical polar coordinate, isn't it?
Yes,
That is
sir.
theta is equal to alpha. In the
Alpha.
cylindrical coordinate system, how many variable you are using? 2 variables, R and Z. tan alpha is equal to r by z, isn't it?
Yes, sir.
But into the Cartesian coordinate system, how many variables you are
Three.
using? 3.
3 variables.
So obviously I will go for the one variable, na?
Okay.
That will be
okay,
much
thank
easier.
You.
Okay.
Thank you, sir.
Okay, great. So I think you people are happy with all the classes. If you have any suggestion, please let me know. Okay.
Yes, sir.
Okay. Thank you.
Thank you, sir.
Thank you so much, sir.
Thank you.